Okay, solving inequality applications. We're just going to do a couple. First one is one where we have to set it up, so it's a geometry case. Alright, so solving applications, you can use any of the methods that we talked about to solve these, but the hard part typically is the setup. Right? Once you get it set up, then it's not too bad. Alright, so this is a geometry type. I have a rectangle that is 4 feet longer than it is wide. The area of the rectangle must be less than or equal, so there's my inequality, less than or equal to 672 square feet. Find the possible values for the width of the rectangle. Alright, so set it up, my rectangle. So if I draw my picture, I've got length and I've got width. Right? And so width, let's suppose it's x feet. Length then has to be 4 more feet than that, right? So I have to have x plus 4 to be the feet of the length, right? Because it's 4 feet longer than it is wide. So if the width is 10 feet, the length has to be 14 feet, right? So you have to add 4 to that. Then what we want to do is we want to find the area and make sure it's less than or equal to this amount. And so area, length times width or base times height, and so area is equal to x times x plus 4, and if I simplify that, I distribute my x, so it's x squared plus 4x, and don't forget the x times 4. Now, if students are going to forget something, they're going to forget that. That's a very common mistake students make. So there's the area in terms of x terms, right? The length is x plus 4, the width is x. And then I want that area to be less than or equal to 672. And there's the inequality I have to solve using any of the methods that we talked about. Right, so first step is move that constant to the other side, right? Make it set to 0. And so the inequality is x squared plus 4x minus 672 less than or equal to 0. And now it's up to you however you want to solve it. Right, a lot of students will try to solve these. You can use the quadratic formula to find the, again, right, remember the first step is we want to find the zeros. So where does it equal 0? And again, a lot of students will set this up. You can use the quadratic equation. You can use the table method. Most students are going to use the graphical method, and so that's the method I'm going to do. I'm going to graph this function. All right, so I'm going to graph it in my calculator. Make sure my window's big enough, so I might check my table to make sure my window's big enough. And then find my zeros. Alright, so when I graph, I'm going to solve this graphically. Because again, I think most students will solve it that way. You do have to make your windows significantly big. Alright, so I went 100 out. And so there's the graph of the function. So there are 2 zeros. There's a 0 here, and there's a 0 there. But the 0 over here would be negative, right? Because of the x values in the side. And so I don't want that 0. The only 0 that I want is the positive 0 because x stands for a distance, right? It's the width of my rectangle, and my width can only be positive. It doesn't make sense to be negative. So I only find the 0 on the positive side. So again, remember the calculator asks you to go to the left, the right, then guess. Alright, and so on the calculator it should give you the answer 24. Alright, and so the 0 is 24. Alright, that's just the 0 where it's actually equal to the 672. It's equal to 0. And then I want the part that's less than it. So less than it means the negative side. Keeping in mind the x values have to be positive, right? Because they're the width. And so keeping that in mind, this is the part I want. Right? That's the less than, right, negative part. I can't keep going for forever because it doesn't make sense to go past 0. Right? So the only answers that work are anything from 0 to 24. So my answers are my x values are less than or equal to 24, greater than or equal to 0. Right? So I can have my width be anywhere between 0 to 24, and then my area would be between 0 and 672, right? At 24, my area is 672. At 0, my area is 0, and that's the smallest area I can have. And so there's my answer. All right? The width, read that, can be between 0 to 24 feet. Which means the length can be anywhere from 0 to 28 feet. They didn't ask for the length, but the length would be 4 inches more, and you can't go past 0, so it'd be anywhere from 0, actually, if the width was 0, I guess technically it would be from 4 to 28. Right, but they didn't ask for that. This is the answer. Right, so again, the hardest part about this one is make sure your answers make sense in the application, right? If a negative number, in most applications, negative numbers don't work. If a negative number doesn't work, stop right at the 0. These are the only parts that I want. Anything that's positive, x values, where my function is negative. And that'll work. Now let's look at my next example. Now this one's a little easier because it's already set up. So this is again our height one. This is again a common one in physics. So the height of the golf ball after t seconds is given by the function 80t minus 16t squared in feet. After how many seconds will the golf ball hit the ground? Over what time interval is the golf ball 64 feet or more above the ground? Alright, so A, the first question is, when will it hit the ground? Well, it hits the ground when the height is 0, right? It starts on the ground, it's going to go up, and it's going to come back and hit the ground, right? That's the shape, that's the arc it takes. And so at that moment, h is 0, height is 0. And so I want to find when my function equals 0. So when my 18t minus 16t equals 0. And this is the t squared, 816t squared. This is the special case where there's no constant. So I can solve this by factoring out the t. So when I factor out the t, I have 18 left over in my first spot, minus 16t in my second spot. And so times 0, it's on the ground, and that should make sense. That's where we're starting, right? We're starting at times 0 on the ground. Alright, then it's going to tee off, go arch up and arch back down, and I want to figure out, well, when does it come back to the ground? This is when it's in the air. Ground. Well, I've solved the second one. 18 minus 16t equals 0. Alright, so 18, 18. I think I switched to 18. This should have been 80. Sorry, guys. 80t. For some reason, I wrote that down. I wrote it down as 18. 80t. So wherever I had an 18, change it to 80. Alright. 80t, 80 minus 16t, so that should be 80. Now I get 80 divided by 16 is my time. So 80 divided by 16, which comes out 5 seconds. Alright, so the ball is in the air for 5 seconds. So it comes back and hits the ground, so the answer is 5 seconds. It takes it 5 seconds from the point it's hit to go up, arc down, and then hit the ground after 5 seconds. Alright, so 5 seconds is the answer to A. Alright, part B is over what time interval does the golf ball 600 feet or more above the ground? Alright, so we want to know when our height is greater than or equal to 64, right? 64 feet or more includes the 64. And so I solve 80t minus 16t squared greater than or equal to 64 is the inequality I want to solve. Alright, so again, isolate the 60, move the 64 over, make it equal to 0, so minus 64, minus 64, and I might rewrite it just because it's more comfortable to write it square term first. 16t squared plus 80t minus 64 greater than or equal to 0. Alright, there's the inequality I want to solve. And so it's up to you. Again, there's a bunch of different methods. You can use the table method. You can use any method you want. I think most students will use the graphing method. All right, so I'm going to use the graphical method. And I believe a standard window should work just fine when we type this in. I'm going to double check and make sure it does. Since I wrote it down wrong earlier, I'm going to double check myself this time. Alright, so zoom standard when you go to graph it. Alright, and it does. Now, when you graph it, part of it's off the page, but really the only parts I really care about are the zeros. So the zeros are in here, and then it shoots up really fast and comes back down. Now it does turn around, you just can't see it on your page. Alright, so there are 2 times that are in the positive region. Right, those are both on the positive side. And so there are 2 answers, those 2 x values that I have to find. Alright, so remember you hit second, trace, solve, and you'll have to do it for both of these, first side, second side. And so the first value is 1. And then you do the exact same thing for the second one. Remember, left side, right side of it. And that comes out 4. Alright, so at 4 and 1 second, it is at 64 feet. And then we want it to be positive, right? We want it to be above 64. And so that's the positive region. So it's all of this is positive. So between the 1 and the 4, including the 4 and the 1 because it's equal to. And so the answer is, over the time period less than or equal to 4, greater than or equal to 1. And it should make sense that it's between 0 and 5, right? The golf ball's in flight for 5 seconds, so it should be, time should only be within 5 seconds. All right, so it should make sense that this is the case. All right, there is an alternative way to solve this, so there's the answer. All right, seconds. Just an alternative, so a second method. All right, we want to know when the height, again, same question, greater than or equal to 64. It's going to be solving it graphically, but I'm going to do it slightly differently. I'm going to graph both the h of t on my graph. So I'm going to let that be graph 1. So I'm going to let y1 be my 80x minus my 16x squared. y2 is going to be 64. Alright, and so when I go to, so I have 2 graphs. When we go to graph that, so I am going to have to adjust my window. I've got to go up to at least 64, so I'm going to let my y maximum maybe be 100 so that I can see it. So when I go to my window, that's the only one I'm going to change. The rest of them I'm going to leave 10 and negative 10. The only one I'm changing is the y max. All right, that's it. It's the only one I'm changing. And so if you do that, the graph on the calculator should come out. So again, this is 100 up here. That's still 10 and negative 10. You know, everywhere else. All right, so it comes up, comes down, again goes after that. So there's h of t. And then there's a second line that comes through. That would be the 64. And we want to know where is it 64 or bigger. And so that would be at the 64 and everything bigger. And if you check it out, where you do the intersect in this case, not the zeros, you would find it intersects at 4 here and at 1 there. And so you get the same answer. The function is greater than or equal to 64 between 1 and 4. And so that's an alternative method that you could use. And if some of you use that method, that's fine. There's actually other methods too. Those are the 2 most common methods that students typically use. And that finishes up 3.4, only one more section to go, which we're actually going to kind of veer away. So we've done all this stuff with quadratics. The very last section, we're going to kind of veer away from that a little bit. We're going to be talking about transformations, how graphs move when we add, subtract, and multiply by numbers. And that's the last section in Chapter 3.